Why do we need separation techniques? A separation technique is used to separate substance in a mixture without changing their chemical properties. We choose different methods based on difference in particle size, boiling point, solubility, and affinity to solvent. First is filtration. Filtration is simply to filter to separate insoluble solid from a liquid. For example, we want to remove sand from water. Then what we will do? We will just pour water with sand into the filter, and water will be separated downward, and sand will be has a residue over there. Okay, so principle work because the filter paper has tiny pores and liquid can pass through that, but insoluble solid will be trapped. What are the apparatus we use? The apparatus are filter funnel, filter paper, beaker, conical flask. Key terms in this is residue. Residue is the solid left on the filter paper. For example, sand. Filtrate is the liquid collected below. For example, water. Okay. Example is sand and water and chalk plus water. Okay. Salt plus water, they dissolve. So we cannot do it like this. So insoluble solid plus liquid is filtration. That is an important thing for past papers. What is distillation? Distillation separates solvents from the solution. Liquid with a large difference in boiling point. Okay, we will boil. For example, if the boiling point of water is 100 and boiling point of ethanol is 65, for example, Celsius. So what we will do, we will increase the temperature till the temperature reach 70 degrees. Then we will extract ethanol, and after that we just have water in the solution. In this way we can separate two solvent from a solution. Different substance boils at different temperature. Okay, steps that we should take is to heat the solution. Lower boiling, liquid evaporates first, vapor enter condenser, vapors cool down and liquid is collected. Salt water boils at 100 Celsius, salt does not evaporate. Okay, so result is pure water collection, and water with salt remain there. That we use for the sea water to collect fresh water from the seawater. We use that technique. Okay, for desalination of seawater, or fractional distillation that we used for hydrocarbons. Okay, for hydrocarbons. What are hydrocarbons? Hydrocarbon is petrol, diesel, air, jet fuel, jet fuel, and a lot of other things. Definition is two or separates two or more miscellaneous liquids with a similar boiling point. Difference from simple distillation uses of fractioning columns. The columns allow repeated evaporation and condensation, improving separation. Okay. Example is ethanol plus water that I have already given you. That ethanol uh, boils at 778 Celsius, whereas water 100 Celsius. Ethanol come off first. It is used to separate crude oil, producing alcoholic drinks, separating liquid air. Okay. Now the next thing is chromatography. Separate substance dissolved in the solvent. Okay. So principle, for example, we have four different molecules, the solvents in the solution. So everyone will be projected on different base based on their solvent. Okay. So different substance travel at different speed. So speed depend on the attraction to the paper. Steps: draw pencil baseline, place samples, put paper in the solvent. Solvent rises, component separates in the spot. Important terms is baseline, ink dissolve. Solvent front, further point reached by solvent using food coloring. ink analysis, drug testing, forensic science. RF is equal to distance moved by the solvent front divided by distance moved by the substance. Okay, always measured between 0 and 1. Okay, we will do more in detail if you take online classes from me. Okay, that is just a overview. Crystallization: obtain pure soluble solid from a solution. Okay, what we do, we just boil the that water or any solution and till we get solids particles. Okay, and then we cool them off and then we get our crystals. Okay, as water evaporates the solution becomes saturated. On cooling, crystals form. Okay, so for steps are: heat solution gently, we cannot give it a lot of heat at single time. Evaporate some water. Stop heating before completely dries. That's an important thing. And then you have to cool the solution. Crystal forms. Filter and dry crystals. Okay, filter the dry crystal. Example: copper sulfate crystals. Okay, which not evaporates to dryness. Some salt decompose on very strong heating. Okay, that's all about it.